In this video, I will discuss a JEE Advanced PYQ from the topics electrostatics and mechanical properties of fluids. This question is based on Coulomb's law, which gives force between two charges, so Q1, Q2, separated by a distance d. The force between them is 1 by 4 pi epsilon naught, product of the charges by the distance square. This is the force if the medium between those two charges is air or vacuum. But suppose this medium has a dielectric constant K, then the force, instead of epsilon naught, we have to put K epsilon naught. So the force will reduce by a factor 1 by K if K is greater than 1, which is usually the case. Another concept that is used in this question is buoyancy force. Suppose there is a mass, say suspended from a support, which is a string. The forces acting on this mass or its weight due to the gravity which is downwards and the tension in the string. But suppose I immerse this mass in a liquid. Of density, say rho L. Now a new force will act on this mass, which is the buoyancy force. Let me call it FB. The buoyancy force is because the pressure the liquid in the bottom part will be higher compared to pressure here. So because of that, there will be net force in the upward direction, which is the buoyancy force, and this buoyancy force is equal to the weight of the liquid that's displaced. When the mass is immersed, so this much volume of the liquid will get displaced. So that weight of the displaced liquid is the buoyancy force. So this is equal to mass of the liquid displaced into G. And mass of the liquid displaced is the volume that is displaced into density of the liquid into G. So this V is this volume. So with these basic ideas, we can solve this JEE Advanced question. This is a question. Two identical non-conducting solid spheres of same charge are suspended in air from a common point by two non-conducting massless strings of same length. At equilibrium, the angle between the strings is alpha. The spheres are now immersed in a dielectric liquid of density 800 kg per meter cube and dielectric constant 21. If the angle between the spheres remains the same after immersion, then option A, electric force between the spheres remains unchanged. Option B, electric force between spheres reduces. C, mass density of spheres is 840 kg per meter cube. D, tension in the strings holding the spheres remains unchanged. You can pause and attempt this question. So there is a fixed support and two non-conducting spheres will have some charge, say Q, and this angle is alpha. This is the first case. In the second case, the same thing. But in between there is a dielectric medium of dielectric constant, say K. And the angle alpha is the same. So let us draw the forces acting on this mass. Let the mass of the sphere be M. So there is a downward force mg and there is tension in the string T. Two like charges, so there will be a repulsive force in this direction. So these are the three forces acting on this single charge. Here this forces will be the weight mg, repulsive force F could be different, let me call it F2, and tension could be different, we have to check, let it be T2. In addition to that, there is a additional force which is the buoyancy force, because this thing is immersed in a liquid of dielectric constant K. So there will be a buoyancy force Fb. So here the vertical balance this vertical line and the vertical line here, this angle is half angle alpha by 2. So this angle is alpha by 2. So vertical force balance mg is balanced by T cos alpha by 2. Mg equal to T cos alpha by 2. And horizontal F is balanced by T sin alpha by 2. Similarly here, vertical balance is mg is balanced by T2, alpha is same, that's given in the question, plus this buoyancy force. And in the horizontal direction, F2 is balanced by T2 sin alpha by 2. And F2 is the Coulomb force. Coulomb force is 1 by 4 pi epsilon naught into the product of the charge by distance square. So here it's epsilon naught, here is k epsilon naught. So F2 is F by k, because Coulomb force goes down by a factor 1 by k if the medium between the two charges is a dielectric medium dielectric constant k. So first option, electric force between the spheres remains unchanged. So that is not true. Electric force between the spheres reduces. It reduces by factor 1 by k. So A is false, B is true. So from here itself we can conclude A is false, B is true. Option C, density of the sphere and tension of the holding space remains unchanged. That you have to check T2. Okay. So let me call this equation 1, equation 2, 3, and then 4. So T2, if we compare this and this, tension is F by sin alpha by 2. Here tension T2 is F by sin alpha by 2 and then 1 by k factor is there. So T2 is reduced by a factor 1 by k. So option D is wrong. Tension T2 from here is F by k into 1 by sin alpha by 2 and tension is F by sin alpha by 2. So T2 is 1 by k times the original tension. So tension has also gone down by a factor 1 by k. So only thing you have to find out is the density of the sphere. So if I divide 2 and 1, two by 1 will give me F by mg equal to tan alpha by 2. So here I have to eliminate T2 from here. So I'll use 4 and 3. To eliminate T2. So that will give me mg equal to, the third equation will become mg equal to T2 is f by k into 1 by sine. That is T2. I'll put it here. Mg equal to T2 is f by k 1 by sine alpha into cos alpha by 2 plus buoyancy force, which is weight of the fluid displaced. So that is density of the liquid into volume of the sphere, that is Bv. This is mass of the liquid displaced into G. So this is the buoyancy force. Volume of the liquid displaced into density of the liquid, as mass of the liquid displaced into G is the weight of the liquid displaced, which is the buoyancy force. Here the sphere is fully immersed in the liquid, so the total volume of the sphere is the volume of the liquid displaced. And here, from here I can get f by tan alpha by 2. F divided by tan alpha by 2 is mg. So f by, this one is f divided by tan alpha by 2, that is mg. So this is equal to mg by k plus density of the liquid, it's given in the question, 800 kg per meter cube. Density of the liquid into V into G. So mass of the sphere is density of the sphere I can write this as mg to 1 minus 1 by k equal to 800 Vg. Mass of the sphere is density of the sphere into the volume of the sphere. So Vg will cancel, V into G will cancel with this one. So 800 equal to the solid density into 1 minus 1 by k. Dielectric constant is 21. 1 by 21. So this is 20 by 21. So density of solid is 800 by 20 into 21. So this can also be written as, I'll do it here. It's 800 plus 1 by 20 into 800. 21 by 20 is 1 plus 1 by 21. So 1 will give me 800 and 1 by 21 is this. 1 by 20 is this term. So this is 800 plus 40. So answer is 840. SI units. Option C says density of the sphere is 840 kg per meter cube. So option C is true. So B and C are correct options. That's the correct answer. So this is what is explained here. First case, two charges, the forces are mg, the repulsive force because two like charges, and the tension. In the second case, it's immersed in a liquid of dielectric constant K. So the Coulomb repulsion will become F2 and the tension will become T2. Additional force is the buoyancy force because of the liquid in which it is immersed. So force balance in the vertical direction, T cos alpha by 2 is mg because this is alpha. So with the vertical, by symmetry will be alpha by 2. So the same angle is here alpha by 2. And in the horizontal direction, T sin alpha by 2 is balanced by this Coulomb force F. Here, in the vertical direction, buoyancy force will come in addition to the tension component. So Fv plus the tension component equal to mg. Horizontal direction, the same thing. Tension component equal to F2. But this F2 is reduced by a factor 1 by K because the Coulomb's law, it's 1 by 4 pi epsilon. And epsilon is K epsilon naught, where K is the dielectric constant of the medium. And K is 21. So option A, electric force remains unchanged. That's not true because electric force will go down by a factor 1 by K. Option B, electric force reduces by a factor 1 by K. So B is true. C, option D, tension in the string remains unchanged. But here tension T2 is F by K into 1 by sin alpha 2. Here the tension is F into 1 by sin alpha by 2. F by sin alpha by 2. So tension also has gone down by factor 1 by K. So tension has reduced. So it says unchanged. So option D is not true. So this has to be checked. Density of the sphere. To get that, 2 by 1, I'll get F by mg. I'll eliminate tension, 2 by 1, I'll get F by mg. And then 4 in 3 to eliminate T2. So Fb plus, Fb is the weight of the liquid displaced, which is mass of the liquid displaced into the G. Plus T2 cos alpha by 2. And T2 is F by 21 into tan alpha by 2. T2. So Fb plus, Fb is this one plus T2 cos alpha by 2. And T2 is F by K sin alpha by 2. Now here there is a cos, that's why it becomes tan. That's equal to mg, weight of the sphere, which is density of the sphere into the volume into G. And this one F by tan alpha by 2 will come from here, which is mg. And mg is density of the sphere into volume into G. And K is dielectric constant, which is 21. So from this I get density of the liquid, density of the solid as 840, density of the liquid is given as 800.